Well, hi, good morning. Thank you so much for coming and spending some of your time with me here in my shop while I work on this very old 1920, 1939, 1940 radio, something like that. Today's focus is going to be on the crystal. The crystal is sitting right here, the crystal in the holder. And I need to understand this. I think it's quite clear that not fully understanding what's going on with this crystal and the circuit around it is going to make it very difficult to ensure that the performance of the radio is where it should be. One thing about this is part of the IF filter system, and it creates a very, very sharp filter effect. And the result of that is you would only want to employ this when listening to things like CW, like Morse code. Interesting question what it would do with FT8, but I'm not about to attempt anything to do with FT8 in an old radio like this. But narrowband broadcasts might be enhanced, I guess, by the use of this crystal. Otherwise, you probably wouldn't want to employ it, and for that reason, it's probably not very important anymore in the radio, really. But I am very curious about this. I have another radio with a crystal filter in it. It has a phasing control on it. I've never fully understood how it worked. So this is my chance here to figure out what's going on with these crystals. Now, where is the crystal exactly in here? Well, I think it's this white strip, or it's underneath or behind this white strip. That's what I think. There's a couple of retaining screws here that are just holding this thing together. But, does that white thing look like a crystal? Yeah, it doesn't look like a crystal. So I don't know what they're doing in here exactly. And the connections here are curious too to me. Just the look of it is kind of unusual. Doesn't look very good, actually. The solder job here does not look particularly good. The other lead is kind of tucked inside the holder here. So I have read people with this radio take these apart, clean the crystal in alcohol, dry it up, and this was inside of a metal can. Here's the metal can here, filthy inside, but nice on the outside. Whoa, what happened inside? But this would provide a lot of protection sitting on top here. It's not hermetically sealed by any means, but what exactly would you be cleaning from the crystal in there? Another thing that can be done is there's a couple techniques, pretty simple stuff, to try to determine the frequency of vibration of this or resonance of this. A little loose there. Okay, that's what it's all about. I think we're going to take a look at the circuit and just kind of get square how it's arranged. There's parallel and series capacitors and stuff happening. It's complicated to make this work. And there's, I've also read that my other radio is a Hammerland, which has a crystal filter in it. It works on has a different approach from this guy. These things have an inherent problem in them, and that is they have an internal capacitance, so a signal can ride the capacitance right through here. And there's a couple techniques to counter this capacitance. What I'm doing is I'm looking to see if any of these connections are actually loose. This doesn't look so good. Right down, yeah, big finger. Right down here. Where did I see it? Let me wiggle it again. Seems to to be a relative motion between this piece sticking out and the bracket here. As if it's not actually soldered properly right in here. Is that really true? Gee, I don't know. Okay, schematic. Let's take a look at the schematic first. So as I stumble on things of interest here, I'll put them up on the screen while I'm reading. This is coming out of one of the official national HRO manuals. Just this paragraph here. It says, the crystal filter located in the first intermediate amplifier stage provides a convenient means of obtaining adjustable selectivity when receiving any frequency in the tuning range of the receiver. The phasing control associated with the crystal filter enables the operator to easily suppress interfering signals, which may produce objectionable heterodynes. Heterodyne would be a tone or a whistle you'd be hearing. The crystal filter may be used advantageously in either CW or MCW reception. So it's just start right at the start there. Crystal filter located in the first intermediate stage provides a convenient means of obtaining adjustable selectivity. The phasing control associated with the crystal filter enables the operator to easily suppress interfering signals. So I imagine the way that's being done is the crystal filter has a notch, a naturally occurring notch in its response curve, and you can move the notch around by using the phasing control. Now, a naturally occurring notch, I'm not sure about that. But anyway, there we are. That's the first little bit on the crystal filter. So its main purpose is adjustable selectivity and notch filtering. So for sure on my other radio, the phasing control, the control that's labeled phasing, really does seem like a notch filter being moved around, and it really does. May kind of knock out one sideband or the other sideband, or part of one sideband or the other. And it's quite effective. Okay, I'll carry on here. Okay, a little further on in the document, I found this paragraph which really explains the crystal operation. I'm going to read this too. A crystal filter is included in the HRO 5 radio receiver as a means of providing adjustable selectivity. Okay, so I don't have an HRO 5 on the bench here. I've got an HRO 2 or something like that. But this still applies, I'm sure. The use of the crystal filter also enables the, I'm sorry, let me back up. The HRO 5 radio receiver as a means of providing adjustable selectivity. So there's the first statement. They're saying why this is in the radio. It's for adjustable selectivity. The use of the crystal filter also enables the operator to easily suppress an interfering signal by means of the phasing control. With the crystal filter switch in the off position, your receiver bandwidth is approximately 3 kilocycles at 2 times down. So 2 times down. Now I've never heard that phrase used before. I think in the modern world we would look 3 decibels down on the response curve and then pick off the bandwidth at that point. So I'm going to guess 2 times down means almost the same thing, if not exactly the same thing. It's probably clear in some diagrams somewhere in this document. Switching the crystal filter into the circuit gives a bandwidth of approximately 2.5 kilocycles in the broad position and about 200 cycles in the sharp position, and that is sharp, holy smokes, of the selectivity control. Yeah, 200 cycles. So if you're listening to an AM broadcast signal with the crystal cranked down to 200, you just wouldn't hear any trouble. In fact, you'd be lucky if you heard anything. Just a muffled bumping of very low pitched sounds. The phasing control can be adjusted to suppress interfering signal frequencies differing from the desired signal frequency by 300 cycles or more. That's kind of interesting. You can't get closer than 300 cycles. I wonder why. I think this feature is comes along with the crystal, and engineers have figured out how to utilize this thing about using a crystal filter, the notch effect, by employing a variable capacitor, which they call the phasing control. The crystal filter employs a bridge-type circuit, which makes use of the high rate of reactance change with changes in frequency provided by a crystal to give the desired sharpness of selectivity. So what they're talking about here is a crystal filter has a certain reactance, and when you hit its resonant frequency, if that's the right word for it, its oscillating frequency, or whatever you want to call it, and it begins to oscillate, then its impedance changes dramatically and very, very sharply. And that's far better than a capacitor coil, like a tank circuit. It's much sharper than that. So that's why they employ these things. The reactance versus frequency characteristic of the crystal is modified by damping or loading the crystal. Now, is that two things, or is that the same thing being said twice? By damping or loading the crystal by means of the tuned input circuit. Tuned input circuit. Reactance versus frequency characteristic of the crystal is modified by damping or loading the crystal by means of the tuned input circuit. When the input circuit is detuned, its effective resistance decreases and damping is greatly reduced, producing maximum selectivity. I think I'd have to read that a few more times to understand what they're saying there. Detuning the input circuit does not materially affect the amplification of the receiver at the resonant frequency of the crystal, since the series impedance of the circuit becomes very low when damping is reduced. Yeah, okay, that's not sinking into my head right off the bat, but suffice it to say, there's two functions going on in this crystal. One of them is the one they really want, which is the sharp reactance that it provides to a key frequency, its resonant frequency, and the other one is this notchy thing, which you can take advantage of. I think that's probably the way it's operating. Okay, I'll carry on and see what more I can find out. And by now my coffee's cool enough I can drink it too. This might get a little bit repetitive, but here's another section. Immediately above the B+ switch is the phasing control and the crystal filter switch. When this control is rotated to 0, the crystal filter is disconnected. The crystal is shorted out. It's not really disconnected. When the control is at any other setting between 1 and 10, it acts as a phasing control with the crystal filter connected in the circuit. The phasing control is used to balance the crystal bridge circuit in eliminating interfering signals. So there's a little bit more there. Balance the crystal bridge circuit. Okay, that's what the phasing part is about. The selectivity control is located above the phasing control. With the crystal filter in use, minimum selectivity will be found with the pointer nearly vertical. Oh, I don't think I found that at all. With the crystal filter in use, minimum selectivity will be found with the pointer nearly vertical, where receiver background noise is a maximum. Maximum. What? With the crystal filter in use, minimum selectivity. Oh, what do they mean by this term? Minimum selectivity. You can interpret this in the opposite ways. This phrase. So minimum selectivity, I would say, means maximum bandwidth. Will be found with the pointer nearly vertical when the receiver background. So that makes sense then. Okay. Because the first time I read this, I read this the other way around. This would be where the selectivity is tight. Rotating the knob in either direction from this point will progressively increase selectivity. When the filter is not in use, this knob acts as an ordinary IF trimmer and should be set at the point giving maximum volume and sensitivity. I haven't read any of this anywhere else except here. When the filter is not in use, this knob acts as an ordinary IF trimmer and should be set at the point giving maximum volume and sensitivity. I guess maximum volume and sensitivity is the same thing. Okay, that's interesting. That adds a little more to the picture. Now I know that there's a bridge circuit. The crystal's in a bridge circuit, and that's how they're managing to manipulate this notch effect. I've also found out when you have the crystal phasing control at 0 and the crystal is shorted, then you continue to operate you can continue to operate or change the position of the selectivity, but you're not really changing the selectivity anymore of the radio. You're changing, you're tuning the IF. Is what it sounds like, an ordinary IF trimmer. Okay. Just reading this very quickly for the rotation. Okay, that's something else. Okay, fine, I'll carry on. Whoa, I didn't actually drink any coffee yet. What? I gotta go drink some coffee. Okay, we're at the front page of this document. I wanted you to see what it is I'm reading through, because this is actually quite detailed. More detailed than others manuals I've come across, and there can't be that many manuals. I'm sure those who are experienced with this radio will recognize this manual. This is from the National Company, and I'm down on page 10 now, where another section is written about the let's see, where are we here? Page what? Page 16. Whoops, way too far. Another section is written about how to use the page 10. Here we are. Reception with the crystal filter. So this is about a page and a half of writing here explaining in detail how the operator utilizes the crystal filter. So let's just read through it. I haven't read this entire thing. I just looked at how much it is. So let's see. Reception with the crystal filter. The crystal filter may be used advantageously in both CW and MCW reception to adjust the selectivity of the receiver and also to suppress interfering signals. So there's the two key things. Again, for MCW reception, and what, I'm really not a very good ham radio operator. I don't know what the M is here. MCW reception. The crystal filter is switched into the circuit by turning the phasing control knob from 0 to 1 as indicated by its dial. The insertion of the crystal filter reduces the receiver gain slightly, and as a result it will be necessary to advance both AF and RF gain controls to compensate for this loss in gain. It says slightly. Then it tells you to turn both these controls up. The phasing control should then be turned to the center of its range, which effectively removes its action from the band of frequencies being received. Which removes whose action? Crystal filter action. The crystal filter action removes the crystal filter's action from the band of frequencies being received. Does it? The selectivity control may be adjusted for minimum selectivity by turning it to a position near the center of its range where the background noise is the loudest. Okay, so the loudest background noise, you've got the widest setting. Adjust it for minimum selectivity. There, they did it again. I'd say maximum bandwidth. That's what I would write there. But minimum selectivity by turning it to a position near the center of its range where the background noise is the loudest. The receiver may now be tuned to the MCW signals in the usual manner, but it will be found that the selectivity is very high, with the result that all audio frequency tones above a few hundred cycles are comparatively weak when the receiver is tuned exactly to the MCW carrier. Normally, this loss of high-frequency audio tones would result in low intelligibility of the received signal. But since the background noise, static, etc. have been reduced much more, the net result is usually an improvement. So just narrowing the bandwidth, you're just letting in less and less noise with the signal. And if the signal is a narrow bandwidth signal like CW, then you can achieve, you can hear the signal just fine, and you've managed to squeeze the noise out. That's kind of what it's saying here. Just in case you don't understand. Boy, what an insult, Jim. Shame on you. Everybody understands this. Selectivity may be increased for use in extreme cases of interference by turning the selectivity control in either direction from the minimum selectivity position. Under these conditions, tuning is very critical and care must be exercised to assure proper tuning. Right. I have experienced how sharp this radio is when you have the stuff turned on. An interfering signal which produces undesirable heterodynes may be greatly suppressed by means of the crystal filter phasing control. It will be found that the point of maximum attenuation for signals with a frequency near the desired frequency will occur near one extreme or the other of the phasing control rotation, depending upon whether the frequency of the undesired signal is above or below the frequency of the desired signal. So what they're anticipating here is that interfering signals really in one sideband or the other, and you can use the phasing control to kind of knock down one sideband and therefore knock down the interfering signal. The other sideband remains. So this wouldn't be too good in single sideband work. I don't know about this. Undesired. So at the time this was written, there was no single sideband work going on, as I understand it. Doesn't make sense. This is 1940. Okay, stop talking, keep reading. Undesired signals with frequencies further removed from the desired signal frequency can be suppressed with the settings of the phase control, which occur near the center of its range. Crystal filter operation for CW reception is similar to that for MCW. I'm going to have to find out what this is, with the exception that maximum selectivity may be employed without loss of intelligibility experienced with MCW reception. When maximum sensitivity is employed, maximum selectivity is employed. So you got a minimum bandwidth. Tuning is very critical and care must be exercised to assure proper tuning. Now you can go right by the signal. It just goes right by. When the receiver is slowly tuned across the carrier of a received signal, the beat note produced will be very sharply peaked in output at a particular audio pitch. This is the peak in response. This peak in response indicates the correct receiver dial setting. So it's not the pitch; it's the volume of the beat frequency that you're listening to. It's the volume. Yeah, okay. The setting of the CW oscillator must provide a beat note peak well within the audible range so the receiver peak response can be readily observed. If you don't have the CW set right, the audio response the audio tone may be so high you can't hear it, or it's snuffed out by the radio by this filter anyway. I'm not sure. The CW oscillator dial setting set near 7 is recommended. After the receiver has been correctly tuned, the pitch of the beat note peak may be adjusted by means of the CW oscillator control to provide an audio tone which is pleasing to copy or coincides with any response peaks in the speaker or headphones. Yeah, very, very much. Morse code was what was being listened to with this radio. Under these conditions, the receiver will exhibit pronounced single signal properties. Under these conditions, the receiver will exhibit pronounced single signal I can't say that properties which may be demonstrated by tuning the receiver dial to the other side of 0 beat so that the pitch is the same as before and observing the marked reduction in output. Maybe what they're trying to say here is single sideband. Single signal properties. I don't know what they're talking about for sure. But that's what it sounds like. You're tuning to the other sideband and it's not there. This dial setting is not recommended for use other than to demonstrate the single, here we go again, single signal properties of the receiver. Yeah, I think this is probably a homage to single sideband. And when the single, just like not only can you not say it, single signal, it doesn't speak as well as single sideband. The operation of the phasing control and suppressing an undesirable signal is the same for CW and MCW. There we are. Okay, well, that was actually quite a bit. I find these old manuals, especially military manuals, have instructions like this, extremely detailed. If you read them carefully, you can't get it wrong, that kind of thing. Fantastic. Okay, I will hunt down some more information about this thing. Well, I think I found another section that certainly refers to the crystal filter system, and I think it's going to be helpful, but I'm going to read through this stuff. It's about getting ready to do an alignment, but I think it reveals a bunch of stuff again about this crystal circuit. So let's read through this. I don't expect to understand it. I just want to know kind of, the area, a bit of an overview of what it's talking about. So intermediate frequency amplifier alignment. I'm right on the edge of doing this, in fact. That's why we're studying this crystal thing. A1. Do I have to be an A1 operator? A1 operator. The operator is cautioned against making any adjustments indiscriminately, and he should not realign any circuit unless tests definitely indicate that realignment is necessary. That's kind of the process I'm in right now. A2. The alignment of the intermediate frequency amplifier may be easily checked in the following manner. Oh yeah, easily. The receiver, this is a check of the alignment. The receiver should be adjusted for normal operation with no antenna, AVC off, RF gain at 9, crystal filter on, phasing control at 5, selectivity maximum. Selectivity maximum. Okay, well, what do they mean by that? So I think that would mean the selectivity control would be either extreme left or extreme right. I think that's what that means. And the CW oscillator's turned on. They're anticipating you using a signal generator in this test that has no modulation, I think. Setting of the AF gain control does not affect the measurement and may be adjusted to provide sufficient output to make the required observations. The CW oscillator control should then be turned until a point is found where the predominant pitch of the background noise is lowest and a crystal ring is heard. What? A crystal ring is heard. Okay, a crystal ring. I'm not sure what they're talking about there. This setting of the CW oscillator control should occur near 9 on the CW oscillator scale, and the exact setting should be noted. The crystal filter should then be disconnected from the circuit by turning the phasing control to 0 on its scale, and the selectivity control adjusted for maximum background noise. So that would be minimum selectivity. The CW oscillator control should again be adjusted for the lowest predominant pitch of background noise, and this new setting noted. The CW oscillator control should be again adjusted for the lowest predominant pitch of background noise. Never heard of anything like this being done before. And this new setting noted. If the IF amplifier is properly aligned, the setting of the CW oscillator control should be the same for both tests outlined above. If the IF amplifier should not be realigned, I'm sorry. The IF amplifier should not be realigned, however, unless the test shows appreciable maladjustment of the IF amplifier. When it is necessary to realign it, the following procedure should be followed. Adjust the receiver, crystal filter connected in the circuit, and set for maximum selectivity. Maximum selectivity. Boy, I gotta read that carefully every time I see that phrase. Connect an antenna, tune in the CW signal. It's tuned exactly on the crystal peak. Yeah, okay, so I'm gonna read all this. This may really come here. Repeating the test of paragraph A2, the crystal filter disconnected from the circuit and the selectivity control adjusted for maximum. Yeah. Okay, we got a little more out of that, I think. What did I gather from this? There's this crystal ring. The crystal ring is heard. We must hear the crystal ring. Okay, let's see what else I can find in this manual that refers to the crystal. This is from a different manual, another military manual, I think. And read this paragraph 3 here. With the signal generator modulation off, tune the generator slowly between the frequencies of 450 and 460 until a sharply peaked response is indicated on the output meter. This peak response occurs at the exact frequency of the crystal, and the generator should remain tuned to this frequency. And that's part of what I was trying to do and seemed to be unable to do, which is be sure what the frequency of the crystal is. It's supposed to be 456 ideally, and they're just giving a very tight range here, so you wouldn't expect it to be too far off. It's going to be somewhere between this 50 and 60 here. It's supposed to be. You know, I did watch a video quite some time ago of people making these crystals, and it came down to a woman with a file filing the edge of the crystal and then putting it in a jig to test it, and then taking it out and filing it some more. I couldn't believe it. It was just a completely manual operation with a file, filing down the crystal to get it to oscillate at the right frequency. It seemed unbelievable to me that it could be done that way, but that's what I saw. Okay. How are we? So is there some way I can test this crystal outside here, sitting on my bench? There must be something I can do. I'm gonna try a few things here. Okay, here's my first bench test. The voltmeter is set to AC, 1.5 volts full scale. You can see it's up just a little wee bit. I've set the probe here for AC readings. Okay, I've forgotten to do that. So I basically have the voltmeter just across the leads of the crystal, and then I have my signal generator running over here. You can see the frequency is 426 right now, and that's resulting in that voltage reading. Or is it? I'm just going to move my camera over here. I think this might be a better arrangement. So first of all, I'm going to change the output level of the signal generator and see that the meter moves. I can't make the meter any more sensitive. That's as high as we're going, and I think that's, well, that's the max output I should be driving my signal generator. I can probably get a little more out of it, but be overloading it. So here I'm going to turn it down, and we can see the meter following along. So the meter is responding. Now, this meter has some upper frequency limit. I don't know what it is. I may have to switch to another meter then. I know the upper limit is very high, 10 megahertz or something like that. So we're at 500,000 hertz. Perhaps the meter is really not doing very well, but the fact that it's indicating something is enough. We don't need an absolute measurement here. So I'm going to vary the frequency now of the signal generator, and can you see that? You can. It says 426 right now. Somewhere between 450 and 460 we should see something happen. And I think if the crystal becomes resonant, then the voltage coming out of the signal generator will rise across the crystal, and we'll see that on the voltmeter. So here we go. So can you still see the numbers? You can kind of see the numbers going up. 440. Okay, I'm going to watch that voltmeter now very carefully. I'm just going to keep turning this up and watching the voltmeter. Where am I? 449. Okay, so I'm not there yet. What was that? I'm at 455 right now. Well, I'm at 470. Nothing happened. So I'm going to go back down. Wow. So there's a lot of problems with the way I'm doing this. I've got to come up with a little bit of a better arrangement. This is a little too raw, just hooking up the leads like that. So give me a couple of minutes here. I'll see if I can maybe throw a resistor in there and somehow get things a little better. So of course, I don't know what I'm doing here. I don't know if there's a chance the crystal is not working for reasons I don't understand yet. And if that's the case, then all these tests are kind of indicating that. But the tests themselves could be bogus. What I've done here is I've just stuck in a resistor. It's a 5,000 ohm resistor. So I'm feeding the signal generator through the resistor, then through the crystal. So the resistor and the crystal are in series. And my thinking here is when you're off frequency, the impedance of the crystal is low. Voltage drop on the resistor would be high. Voltage drop on the crystal would be low, and that's what we're reading on the voltmeter. And then as I cross resonance, hit the key frequency of the crystal's frequency, the impedance would go up, and the voltage drop across the crystal would go up and would go down across the resistor. 5,000 ohms, I picked that out of the blue. Maybe that's the problem. Here we go. I've already hinted, I know this isn't going to work. So we're at 466 to start. You see the voltmeter showing nothing. It's all dropping on the resistor, I assume. And we come along. We're at 460 now. Anytime now, we should see a big whoosh on that voltmeter. And there's no whooshing. We're down to 456. This is the key right in here. I'm going back and forth around 456. I cannot make that needle move. I'm imagining it moving, in fact. 453, 52. Okay, we're going to go way down. Stupidly down. 400. Is there anything going on here? And we're way down to 3 something. Let's go back up. Okay, we're at 440. This is maximum output from my signal generator, by the way. I don't dare push it higher. We're at 480. Anywhere at all. Now, can a crystal be that far out? I don't think so. I think this is either a go, no-go thing. It's either going to work at its design frequency or it's just not going to work. So people are taking these things apart, cleaning them and putting them back together and claiming that made them work. How they knew they weren't working in the first place. Either radio operation, and they knew enough to recognize that the crystal needs to be cleaned, or reset in its holder. I got to read up generally how to test crystals, because this could just be totally bogus what I'm doing here. Not that I normally don't do anything bogus. Yeah, I got to how to test a crystal. Must be something on it somewhere. Okay, let's try this. This is Microsoft's Copilot, your everyday AI companion. I'm not trying to promote this in any way. I'm using it. And you're going to see me use it. Now I've typed in this question down here. How can I test a crystal that is used as an RF filter in an antique radio? Okay, Mr. Bing AI, know-it-all, what do you have to say about that? Okay, we're going to let it blab here for a minute, and then I'm going to scroll back up. This gives you an idea of what kind of response is coming. Okay, what's it say? Testing a crystal used as an RF filter in an antique radio involves a few steps to ensure it's functioning correctly. Here's a general guide. Number 1, visual inspection. Check the crystal for any visible damage or corrosion. Ensure the leads are intact and not broken. 2, multimeter test. Set your multimeter to the continuity or diode test mode. Connect the multimeter probes to the crystal leads. A good crystal should show a very high resistance or no continuity. If it shows low resistance, the crystal might be shorted. How do you short a crystal? Oscillator test. This is kind of what I tried. Connect the crystal to an oscillator circuit. This is not what I tried. This can be a simple test oscillator circuit designed for this purpose. So you've built a circuit that's going to oscillate, and you're going to stick the crystal in it. I think that's what they're saying here. Measure the frequency output of the oscillator using a frequency counter or an oscilloscope. Compare the measured frequency of the crystal's specified frequency. Significant deviation indicates a problem. Signal generator and receiver test. Connect the crystal in the RF filter circuit of the radio. Use a signal generator to inject a known frequency into the circuit. Use the radio receiver to check if the signal is being filtered correctly. Crystal should allow the specific frequency to pass while attenuating others. This might not be true all the time. It would depend upon how the crystal is set up in the circuit involved. Could be the opposite. So, but normally inside the radio, you would want the frequency to pass through it, the resonant frequency. So, right in the radio, use the radio as the piece of equipment to set up the crystal. Specialized crystal tester, if available. No, it's not available. Use a specialized crystal tester. Always ensure you follow safety precautions. Do you have now? This kills me. At the end of all these things, it tries to engage you in a discussion. Do you have a specific model of radio you're working on? That might help tailor further advice. Okay, we'll tell it that. I'm working on a national HRO radio. Let's see what it says about that. Okay, that's a classic piece of equipment! Exclamation mark. Oh my gosh, the Bing thing is excited. That's a classic piece of equipment. The national HRO radios are well regarded for their performance and build quality. Here are some specific tips for testing the crystal in your national HRO radio. Visual inspection, okay. Multimeter test, okay. Oscillator test, okay. In-circuit test. Reinstall the crystal in the HRO radio. Use a signal generator to inject a signal at the crystal's frequency. Tune the radio to see if it filters the signal correctly. The crystal should allow the specified frequency to pass while attenuating others. I think this is a little bit of a problematic suggestion here. Specialized crystal tester. Do you have any specific... Always carry on the conversation. Do you have any specific issues with the radio, or is this part of a general restoration project? It's like talking to a person. I'm telling you. And this has improved dramatically just in the last month. It seems like every week this gets better and better and better. And I do have conversations in which what I type is just ordinary human sloppy language. I type sloppy language in here, and it's just like talking to a person. So I'm pretty excited about this, and I'm finding it very useful. The alternative to doing this, of course, is to search for a website where someone has explained how to do these kinds of things. So, you Google up a bunch of websites and then go through them and see if anybody's done something similar to what you're after, or, something like that. So I find this Copilot thing is fantastic. So, and look, I mean, how obscure is this? I'm working on a radio from 1940, and this thing seems to know all about it. Okay. What it didn't say in this particular version, because I did this on my phone while I was sitting on my deck a few minutes ago, it came up with it says signal generator and receiver test. It came up with another test. It said use your oscilloscope. So I'm going to try that, but I can't imagine it's going to be any different. But let's try that. We'll see what you know what else I could do? I could sweep this thing. Why would that help? I could sweep this. Hey, that's a good idea. Hey, Mr. Bing. Thanks for leading me forward enough that I came up with a better idea here. Let's sweep this guy. Okay, so I have basically the same setup with the crystal. I'm feeding a signal from the sweep generator this time. I still have this 5,000 ohm resistor sitting here. And the scope is connected across the crystal. And we see absolutely nothing right now, but I have a very low output. I'm going to crank it up. I'm going to crank it way up, way up. Something very funny happening right in here. And this is set so that 455 is right in the middle here. So I think we're seeing the effect of the crystal. Can you see that? You can kind of see it. Now, why is it wide here and coming down? Good question, don't know. And I'm hitting this with everything that I've got here. Let me just turn this down a little bit in terms of the sweep. So to determine this frequency now, if I introduced another signal generator, I could bring the effect. I could figure out what this frequency exactly is. Is it suspicious that it's in the middle? Let me change the sweep parameters. I'll make it go higher, and then we should see this funny squiggle point move. Yeah, see it moving? There we go. So I can center this whole display on my scope, and then say this is in the middle, has got to be the middle of the sweep, and it's even right on my sweep frequency counter, which you can't see. It says 456.6. That's marking the center of the sweep. That's what's reported right now on the sweep, on the signal, on the frequency counter, but I don't know if that's really reliable. But it would look like, there you are. Now, is that all there should be? Just this little tiny squiggle here? Shouldn't there be something more going on? Maybe if I increase that resistor a lot. Let me take that resistor way up. I'll put in some kind of huge value here. Let's try, I don't know how huge this is. We'll try, hey, my tray's empty. 5 megohms. 5 megohm resistor here. Let me get one out. Okay, so I'm going to switch the resistor here. Okay, so we're putting the sweep generator signal in through the resistor, which is in series with the crystal. Basically, that's what we're doing. I can see we get this hooked up too. Oh my, that's a totally different situation. Now we're seeing kind of a hum thing happening. Did I turn I didn't turn anything down. I didn't change any of the settings. So we're now sweeping and you can't see a thing. What if I sweep right on the crystal? Forget the resistor entirely. Oops. Then you can't detect the spot. So let's go back to the way it was. I'm going to put in maybe 5 million too big. How about 500,000? Let's try 500,000. Here's one. Okay. Hopefully these are correct in the tray. 5 million, going a little high with the 5 million there. Oop, wrong spot. Go there. And nothing showing. So what this would say is that everything is dropping across this resistor. So this is looking across the resistor and the crystal together. You're basically looking at the signal I'm sending to it. And then if I switch over to the just looking at the crystal, there's nothing left. How can there be nothing left? Because it's all falling on the resistor still. So we'll go back to the little 5,000 one, which maybe was a better choice than I realized at the start. I'm thinking the impedance of a crystal like this is megohms off. Megohms all the time, wouldn't it be? I don't know. I've never put an ohm meter on these crystals. By the way, I have maybe 100 crystals which I can find, we can mess around with. So this might lead to me being able to check all these other crystals I have. Like figure out how to check this one. Now wait a minute, last time around we were seeing stuff. Oh, well, hook up the scope. There we are. Make it more sensitive again. Put it in the center. You see the squiggle? It's just so hard to see. It's just right there. Let's go sensitive, sensitive, sensitive. And I'll bring this down. I can see it better. It's a pretty weird thing, I think. Yeah, I got so the sweep generator I'm using doesn't have a powerful output, which is why we've got the scope set so sensitive. Well, my problem here is this normal? Is this what every crystal would do if I set it up like this? I'll find those other crystals. Okay, let's take a look at a few crystals here. I've got a few, and I got a few more. Holy smokes! Unbelievable number of crystals I've got. I think maybe all or nearly all of these are for CB radio. I don't know. That one says 37.7. I don't know. But these big ones, they look more interesting to me. Let's take a look and see what it says there. 28.775 megacycles, so that's right in the CB band. Well, we can try any one of these. Let's try this. We'll try this. So just replace it. I just change the frequency on the signal generator. Can't go that high. Signal sweeper can't go that high. Can't go that high. We need which one? We need the one. We need something. Oh my gosh, there's such a crystal in here. We need a crystal down below 5 megahertz. Is it 37.750? What would that be for? All kinds of them in here. Tape, all kinds of tape. Somebody put tape around some of them. How is it I have stuff? I don't know what I've got. Channel 10. 23.490. Two of them. These have all been pulled from CB radios that were being scrapped at a shop that repaired CB radios. And I guess as they scrap them, they pull all these out. And it wouldn't take too many radios to fill a bag like this. These ones are also I think it's not the frequency. 28 point something. Well, so I could sweep at that frequency, but I'd have to use this old sweeper, and it's a bit of a hassle here. Okay, let me sort this out and I'll figure out something to do. Can do something. Okay, so I've switched signal generators and I've switched voltmeters. We're now using this voltmeter here. This one, I'm pretty sure, is very, very high input impedance, and it also, I think, goes to a very high frequency too. So 455 kilohertz, easily within the range of this meter. And that's what we're putting into the set here. Let me just, so you can see the connections are the same as they were. It's just I've just switched voltmeter and signal generator and did I say the resistor is still in the circuit? Okay, so this is the original crystal from the radio, so its resonant frequency should be 455 or 456 actually is what they're aiming for. I have this set to AC. I have it on 1 volt. This thing has a terrible time. This takes a long time to stabilize, so I'm going to disconnect it from the circuit. Oops, here. That's the 0 point. You can see what's going on here. This meter is very, takes like about half an hour to really stabilize. So it's only been on for a few minutes, so it's probably going to drift upwards. But we can check that as we go. So I'm going to hook it back up to the circuit. It went up a bit. Good. I think that's good. Now I'm going to vary the output of the signal generator and see if this meter responds. So first of all, use this a little bit. I don't want to drive this meter right over though. I want to keep it a lot like that. I can do this. There we are. We saw it go up. Okay, so this is responding to the signal coming out of the signal generator. Now I'm going to vary the frequency, and we're going to see if the meter cares to show us a change. Okay, Mr. Meter, what do you show us? I'm at 455 going down. It went down a touch. It did a couple things there. Okay, I'm coming back up. Wait a minute, is it jumping around on its own? Me leaning forward, I just touched something and it changed. Okay, seems okay. Let's carry on. 445 going up. Looking for a sudden jump. Ooh. Okay, it jumped up, but it didn't come back down. 453 is going. 458. 467. If I just do this, you can read the numbers yourself. High. Low. I think that's a variation in the output of the signal generator. That's what that could be. Is there? It's got to go up and down. It went up the tiniest amount here. Let me go back. Oh, look at this. You know what? It's inconsistent. Where's the zero on this now? I'm just totally being fooled by the meter. Okay, back on the circuit. Okay, we'll try again. Oh, what was that dip there? Oh. It's a pretty good dip right there. A little bit of hysteresis in my tuning knob. Ooh, now it's going up. It's just inconsistent behavior. Can't figure anything out if it just seems to be randomly moving. Okay, I'm going to disconnect the I'm going to short the crystal out with a clip lead, so it's not in the circuit anymore, and then we're going to watch what happens. Okay, so I can go here, and then I can go here. So this is just basically putting a short on the end of the voltmeter. Okay, well, it should fall right to zero. It's almost certainly just not. Oh, what happened? I didn't do anything and the meter went up. I just leaned forward. I touched this. That's my soldering iron. What's that got to do with anything? Inconsistent test results. So I like watching videos or films, really, of early experimenters at the turn of the century. You can't go back much earlier because there's no recording of them. So around about the turn of the century, turn of the last century, around the 1900s, you start getting film and pictures of these guys working in their labs. Oh my gosh, the labs, they might as well be in a barn somewhere. I mean, it's just horrible. Yet they're making these fantastic discoveries. So I tell myself, even though I got all this kind of junky old equipment here, surely to goodness I can make things happen. I've got enough stuff here to make things happen. That's what I keep telling myself. Now, perhaps this crystal is just not working. So now we're gonna continue this. Only we're gonna use another crystal whose condition is also unknown. I'm just gonna grab one of these, 28.6. 28.6 is good enough. I'm just going to stick it in here. Take the short off. And then we want to just transfer this stuff. I've done nothing with crystals before. Maybe that's kind of obvious at this point. I really have never pursued it in any kind of big way. How do you get this to stay on? It's not a very good connection, but maybe it'll do. What do we get? What happened? So then I'm looking over at the meter. So that's a signal off. No signal. It's not exactly a short on the voltmeter. I check the voltmeter 0 here. I'm going to short it out. That's close. Okay, so that meter's pretty much warmed up now. So that voltage is coming from the signal generator, but it's way off on the wrong frequency, right? This is a 28 megahertz crystal, and I'm way down at half a megahertz. That'll never do. Okay, here we go. This will be the last thing for today because it's a beautiful day outside. What am I doing in my shop? I'm nuts. 28 is pretty high for this signal generator. We might have some trouble getting there. 28. Come on, baby, you can do it. Okay, watching the meter now. It's just going down, down, down. Oh, you know, I didn't check the output. Let me check the output here. The output's very low. We need some juice here. Let's put it up. Did that make the meter go? Not much. So the meter might be picking up just hum and noise and stupid stuff here in my shop, as opposed to the effect of this crystal here. So, get my magnifier. I'm going to read the exact frequency on here. It is 28.685. Just one of the CB channels. 28.685. Here we are, watching the meter now. That's nothing. I'm starting to mutter, so we know this is all coming to an end here. Okay, so that's probably all bogus tests, bogus methods, bogus everything, or I've got two dead crystals here. I think it's more likely I just don't know what I'm doing yet. So that's the purpose of this. The purpose of this is, in my world anyway, the way I operate, I like to be hands-on, then go read some stuff, then come back, hands-on, then go read some stuff. There's no way I can open up a book, read 5 pages of technical stuff and get it in my head. I have to do this iterative thing. I got to see a little bit of reality first, and then I can read the theory and kind of go back and forth. It's an iterative thing. It hasn't worked so far though. Well, maybe tomorrow we can get down to it. So the question is this crystal working? Yes or no? Is there something I should do to it? Clean it? Wash it? Yes or no? I don't know. And how about all these other crystals? Have I got bags and bags of dead crystals that are useless? Or can I figure out a quick way of testing these things and without having to put them, put those ones in a CB radio? That would be the way. That's interesting. Okay, I'll stop humming. Thanks a lot for watching today. Sorry we didn't really get anything much out of it, but you have to climb the ladder one rung at a time. Thanks a lot for watching, and see you on the next video.